Yeah, hi all. Very good evening. So in our last class, we have discussed the theory part about inspection modes. How does a FortiGate firewall inspection happens? Like there are two main modes of inspection. One is called flow-based and one is called a proxy-based, right? Then we have discussed about NGFW policy types also. That is also again have two modes, profile-based and policy-based. Any questions in this?
No questions.
Okay. Then we'll again go little more theories and we'll go to a practical today. So today what we are going to do, let us understand. So first we will understand how does a firewall routing decisions happens, or in what order. Whenever the packet comes into a FortiGate firewall, in what order the routing decision FortiGate firewall checks. Okay, like PBR routes, SDWAN routes, or routing table. Then after we understand this theory, we will go to our labs. During our labs, we will first do routing information protocol, which is RIP. Then we will do OSPF configuration. Then we will do redistribution between OSPF and RIP. Then we will do a BGP configuration. Then we will do redistribution between OSPF and BGP also. Okay, we will understand these things now. Let us go to our theory. So whenever traffic comes into a FortiGate firewall and he sends a traffic, or he need to take the routing decision, or need to decide where I need to send the traffic. Why does we need a routing? To send the traffic out, right? So whenever traffic comes into a FortiGate firewall, firewall need to decide where I need to forward this traffic, right? So whenever traffic comes in, first thing FortiGate will check for this particular traffic, do I have a PBR configured? PBR means a policy based route. Okay, if a policy based route is there and traffic is matching a policy based route, FortiGate will send the traffic to policy based route. If there is no policy based route available, then FortiGate will check do I have a SD-WAN route, or SD-WAN rules we call it. Do I have a SD-WAN rules for this particular traffic? If you don't have a SD-WAN rule also, then FortiGate will come into a third path, which is called normal routing. Okay, in a normal routing it can be a static route or it can be a dynamic route. Okay, so these are the things FortiGate will check whenever FortiGate want to send the traffic out of his firewall or need to take a routing decision. So let us see again. Okay, so if you see, routing decisions in FortiGate are not just based on a routing table. The FortiGate follows a specific order of operation to decide how traffic should be forwarded. Okay, whenever traffic came into a FortiGate firewall, firewall will check a specific order before the traffic is sent out of the firewall. Okay, the routing mechanisms are: first, it would be checking a policy based route. Second, it would be checking a SD-WAN route. And third, it will check a static and a dynamic route. Okay, is it clear? Okay, so now let us understand what is a policy based route. Before we go to policy based route, how does routing happens, or how does any device forwards the traffic? Based on the destination IP, right? Correct. Whenever traffic came into a FortiGate firewall, suppose this is my FortiGate firewall. Whenever traffic came into a FortiGate firewall, this is my source. Whenever anyone is sending traffic, he would be having a source IP and he would be having a destination IP, right? And this particular packet will come to a FortiGate firewall and he need to send a packet out now. So he will not check a source packet. Generally, a device, any routing device will check a destination packet to send the traffic out of his interface, right? That is called a normal routing, forwarding a traffic based on a destination IP address. But when it comes to PBR, it is not only based on the destination. Now with the PBR we are saying, just don't check a destination, please check a source also. Then take a decision that you need to send the traffic where. So whenever we configure a PBR, in a PBR we'll say the firewall or a routing device that not only just take a decision on a destination, but take a decisions based on the source IP, destination IP, then services. Services means a TCP or UDP protocols. Okay, whenever we say services in a class, it would be TCP or UDP protocols. Okay, so not only a routing decisions based on the destination, but we will do a routing decisions based on the source IP or destination IP also. Or we can say based on the incoming interface, we will decide how the traffic should be going out of the firewall. Is it clear? Okay. How it works? PBR is checked before the normal routing table. If traffic matches the PBR rule, the FortiGate forwards the traffic according to the specific gateway or the interface. Whenever we configure a PBR, we will configure specific things like, let us see, 1 minute. Suppose in a FortiGate firewall, I am configuring one policy based route. Whenever I configure a policy based route, I will give specific requirements to a firewall, that what is a source IP, then what is a destination IP, then I will say what is a service. This is optional. Okay, this is optional, service is optional. Then after that I will give gateway and exit interface. Okay, if a traffic is matching my source IP, destination IP and the services, then firewall will say, okay, whatever traffic came into my firewall, it is matching my PBR rule, then I will send the traffic out of this exit interface, or I will forward the traffic to this particular gateway or next hop address. Okay, that's how FortiGate will first check the PBR rule before going to any other routes. Okay, is it clear?
Yeah.
Okay.
Yes.
Okay. If traffic is not matching or any rules not matching PBR rule, okay, any traffic came into a firewall and we have a PBR rule but it is not matching our PBR rule, then second one would be our routing or SD-WAN rules. Okay, SD-WAN rule is nothing but it is a type of PBR rule also, but in SD-WAN we have more granular control, like if the latency is there or jitter is there. Okay, FortiGate SD-WAN rule, intelligence select the best WAN link based on the latency, application type, traffic priority or cost. So let us see how does a SD-WAN rule works in a FortiGate. Now in a normal PBR policy or PBR rule, what we are saying, we will just check a source and destination IP, right? But in a SD-WAN rule, we can check source IP, we can check destination IP, we can even check applications also. If application is like a Microsoft application, Office 365, YouTube, or you are going to any other application, cloud, whatever you are going, we can check anything in a PBR, in a SD-WAN rule. Apart from this, we can check a link utilization or a link, what we usually say, link capacity, or the link is having how much latency, how much jitter is there in the link and all. We can check all these things with the SD-WAN rule. Then based on our rule, the traffic would be going to our exit interface or a gateway. Okay, suppose I am having a source IP as my users. Instead of destination IP, I will say if a traffic is for O365, means Office 365, then Office 365 traffic I wanted to send to gateway 1 or WAN 1. Okay, if latency is less than 50 ms and the jitter is less than 100 ms, then only I will select this particular path as a best path. In a SD-WAN rule, I will tell to a firewall. Okay, just give me 1 minute, guys. Is it clear?
Yes.
Then SD-WAN rules will be taking into a second place. If any traffic
For
is not
this one, for this only we say SLA, IPSLA.
no, IPSLA is something different. Say in a Cisco we call it IPSLA. That is a link monitoring in a FortiGate. SLA tracking, if you are saying about SLA tracking, that is called a link monitoring. In a FortiGate, for SD-WAN tracking, we call it SLA tracking. In SLA tracking, we will not just track a destination, we will track a link utilization or link health also. That is one type of tracking in a FortiGate. Another tracking in a FortiGate is called a link monitoring. Okay. In a link monitoring,
Yeah.
the FortiGate will check if the destination is reachable, then the active or the route would be active, or else the route would be removed. It is like a traditional SLA configuration we have. Okay.
Yes.
Yeah. We'll come to
And
the
one more thing, in PBR, if it doesn't match with the rule, if doesn't match with the policy,
PBR rule.
with it will deny or it will
No, 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 no. It
drop
will go
there.
to second path SDWAN rule.
Mm.
If SDWAN also not matching, it will go to third routing protocol, static or normal dynamic route. It is not like traffic would be dropped. Okay. It is like first I will check whenever traffic came into my firewall. Okay. Suppose I am a firewall, and you are saying you are sending a traffic for me to send it to so and so destination. First thing I will check for a specific source and destination. Do I have a PBR rule configured? Okay. If I have a PBR rule, then I will choose this PBR rule to decide my gateway for this traffic or my exit interface for this traffic. Okay. If PBR rule is not there, no PBR matching for this particular traffic. Okay. Then I will check second rule if I have a SD-WAN rule to match this traffic. If no SD-WAN rule is there, then I will go to third path, which is called a normal routing table or static and dynamic route. Okay. Then if I have a default route to this particular traffic, I will go to default route. If I am having normal static and dynamic route, then I will go to dynamic static and dynamic route, right? It will not like traffic would
Understood.
be matched if a PBR is not matching, traffic would be dropped. Nothing like that. Okay. Is it clear?
Yes, clear.
Okay. So now we understood the source and this normal PBR rule, SD-WAN rule, right? So now let us understand how does a static route and dynamic route works. There are the rules for a static route and dynamic route also. So whenever we need to take a routing decision based on a static and dynamic routes. So assume now we don't have a PBR rule or we don't have a or SD-WAN rules configured in our FortiGate firewall. We are not just having a normal routing. Okay. So whenever we have a normal routing, again there is a decision for a FortiGate firewall. So first decision happens based on a longest match. Okay. Then second decision would be lowest AD value. Third decision would be protocol metrics. Okay. So what is the longest match generally means? 1 minute. Assume whatever this is my firewall. Okay. And I am having two particular things. This is my branch 1. Okay. This is my branch 2. BR1, BR2, or you can assume it like local LAN routers also. Now here I am having one particular network 172.168.1.0/24. Here I am having another network 172.168.2.0/24. Okay. Now assume from this particular here and here they are also running routing protocol or something, or they are having a static route between them also. Now from this particular path, port number 2, port number 1 in FortiGate firewall. If from here in a FortiGate firewall I need to write a two rules now. On a port 2 I have given a route 0000/0 and next hop would be BR2. Okay. Then I have written another rule which is 172.168.1.0/24 BR1 Again another rule I will write, which would be 172.16.2.0/24. Again I will say, instead of BR2, if I say BR1. Okay, now what will happen when the traffic needs to come? Suppose this is my LAN. When the traffic needs to go from a firewall to BR2, instead of taking a default route, firewall usually takes this particular thing, because compared to /0/24 is the longest match, right? Longest match generally means whichever you are having a longest prefix. Okay, compared to 0, our /24 is the longest prefix, right? So instead of going to this particular way, traffic would be going to this particular way. Then it will go here. Okay. So that's how FortiGate decisions have. Not only FortiGate, any routing protocol or any routing device will take a decision based on a longest match first. If assume you don't have this longest match, or for example, now you are having 0.0.0.0, right? If you don't have this particular rule also, then traffic will go to here, because here only 1.0 is matching. 2.0 is not matching on the second rule, right? Here 1.0 is matching, 2.0 not available. Then it will go to a default route. If you are having a 2.0, then it is going to BR1. Then traffic would be going to BR1. Like that, the longest match usually works in a FortiGate firewall. Okay? Is it clear?
Yeah, clear.
Okay. Then second thing, we call it a lowest AD value. What does the lowest AD value means? In the same example, assume now I want to send a network traffic or default network traffic. Internet traffic we generally say. Okay. So I will say 0000/0, then AD value. The default AD value of FortiGate is 10. Okay. Then I will say next hop would be BR1. Then same thing, 0000/0, and if I increase the AD value from 10 to 15, and I will say BR2, then all internet traffic or any traffic coming which is not matching our longest match, suppose this traffic is for internet, then it will take this particular traffic as a best path, because it is having the lowest AD value compared to 15, right? So for traffic would be going to this particular way for a internet purpose. Okay. Assume this is not your branch router now, this is your ISP1 and this is your ISP2. Okay. Then your ISP1 would be acting as active and ISP2 would be standby. Once this particular ISP goes down, then this will automatically come up. Okay. Is it clear?
Yes.
Okay. Then third thing would be, suppose you don't have your AD value is same. Okay. Then what will happen here? It would be happening is a ECMP, equal cost multipath, which means traffic would be load balanced between both of your ISPs. If your AD value is same, your longest match is same. Here what is happening? For our internet traffic, our longest match or prefix 0 is there. Here also 0 is there, right? So this is matching 0000/0. Both the subnet mask are same. So and the AD value also same. So this will be happening a ECMP in our environment. Okay. Traffic would be load balanced between the both of the firewalls. Then third thing would be our protocol metrics, which means if you are not running any static route, then you would be having a routing protocol, OSPF, BGP and all, and they would be having their own metrics to do a best path calculation, correct? That would be taken into a third place. Okay. Is it clear?
Yes.
Okay. So now we will go to our lab environment. Let us go to our lab. Okay. So during this lab, what we will do? We would be having a firewall, and assume this as a MPLS cloud provider, and this is our branch router. Between our firewall and our branch router, we would be running routing information protocol, RIP. Okay. Then inside my branch, I am having two VLANs, VLAN 10 and VLAN 20. Inside my LAN firewall or my DC, and on my branch I am having one subnet 172.16.1.0. Okay, so from a branch I need to advertise this particular route to my firewall, and from firewall I need to advertise 10.0 and 20.0 to my branch router. Okay, so how do we do? Let us see now. So I have added another router in my in my lab environment, and I am connecting that particular router with the firewall with the port number 2. First let us see if I have a router configuration. Mostly I should be having that. Okay, I don't have. Let us configure router. Enable config T. I have given in this particular diagram also that see, for a branch router Ethernet 0/0 we will use 10.1.1.2, and Ethernet 0/1 172.16.1.1, and a firewall port number 2 10.1.1.1. Okay, firewall port number 2 is directly connecting to our branch Ethernet 0/0. Okay, interface Ethernet 0/0, IP address 10.1.1.2, no shutdown. Okay, then interface Ethernet 0/1, IP address 172.16.1.1, no shutdown. Okay, then I will enable routing router RIP, sorry, version 2, no auto summary. Then I need to advertise what network? 172.16.1.0. Okay, done. Then end. Now on a firewall side, I need to configure port number 2. Then I need to enable a RIP on a firewall also. Let us try to do that. So okay, I'll go to network interfaces. On port number 2 I don't have a IP address. Okay, so I'll configure IP address now on port number 2. I will say this as a branch router. Then I will put it as a WAN. Then I will configure IP address 10.1.1.1/24. I'll enable a ping on this particular thing. Okay. Now first let us see what routes we are having on a FortiGate firewall. So whenever you want to get a CLI access directly of a firewall from the GUI, you see this particular symbol, just click on this, you will get a CLI console. Get a router info, routing table, all. So as of now I am having one default static route, then I am having two static routes 10.0, 20.0 pointing towards my LAN side. Okay, but I don't have 172 series subnet, right? Let me ping branch router, execute ping 10.1.1.2. I am able to ping a branch router. I don't have 172 subnet in my firewall now. So for that I will enable RIP. I will say version 2. Then what network we are advertising? 10.1.1.0/24. Okay, I don't want to have any interfaces configuration. Okay, let us see again. Get the router info, routing table, all. Okay, 1 minute. On router side I have not advertised 10.series. 1 minute, hold on. Config T, router RIP, network 10.1.1.0. Okay, let us wait for a couple of minutes. As of now I have not received. Get the router info, RIP, database. Okay, as of now I am getting 10.series, that is RIP and connected only as of now. Not received anything. We'll wait.
I think you have configured 10.1.1.1.
Yeah, yeah,
No,
that's fine.
not he,
Mm-hmm.
the interface side.
Mm-hmm. 10.1.1.1, yeah.
You gave network ID here, a particular IP you give, right? It doesn't make matter. Like,
Which one you are saying? Here 10.1.1.1?
here 10.1.1
Mm-hmm.
you gave, there you gave network ID you
Ah,
gave,
yeah, yeah. Here
zero,
we need to give
zero.
IP and subnet mask, network subnet mask. Whenever we configure a routing, we need to give subnet mask in a firewall. Okay, it should work in a couple of minutes. Let us wait. Now we are getting routes for 172, right? And same thing we should be seeing. This is a database table of a RIP. Get router info RIP database. Okay. Then if I say routing table all, I'm having a RIP in my database, right? So now from a router, I am able to get a RIP routing from a firewall, right? From a router, I am advertising 172 series, and I am able to learn that particular route in my firewall using a routing protocol, correct? Now assume on my router if I wanted to advertise any other route. Suppose I am having one loopback address. Suppose loopback 0 with the address of 172.16.2.1/24. If I wanted to advertise this, again first I need to create one loopback address on a router. Interface loopback 1 IP address 172.16.2.1 Okay. Then again I need to go to router RIP, then advertise this particular thing 172.16.2.0. Okay. I don't advertise this particular interface IP. I'll advertise subnet complete. Now I am getting 2.0 also from my routing table, right? Previously I was having only 1.0, correct? If I remove that from my routing table, it would be removed in couple of minutes. There is a timer for a RIP. If you have done CCNA or CCNP, you would be knowing a RIP timer. If I say no, then this would be removed after 180 seconds or so. There would be a dead timer of a RIP that would be removed. Okay, 1 minute. What I did, just a minute. No network 172.16. Okay, fine. I think everything got removed. Get the router info, routing table, all. This should be coming in couple of minutes. No problem. So like that you will advertise your routing protocol whenever you are running between a firewall and your router. Okay, and in firewall you can advertise this particular routes. Now but in a router, I am not learning show IP router. If you see on a router, do I have 192.168.10.20. What was our requirement? On a LAN side, I am having two routes 10 dot and 20 dot that I need to advertise to my another neighbor. Okay, and on a neighbor side I am having 1 dot and 2 dot that I need to get it from a neighbor. So on a firewall, as of now we have only advertised 10.1.1.0, right? I have not advertised 192.168.10 dot and 20 dot. So now let us advertise that also. We'll see how it happens. We'll say in couple of minutes. Chordo. I'll advertise more network now. 192.168.10.0/24. Then another 192.168.20.0/24. Okay. We'll apply this. Done. Now we'll go to our router. As now I have not received anything. Show running config section router. Okay, 172 also got removed. No problem. Config T router RIP network 172.168.1.1.0. Okay, exit. Show IP route. Of now I have not received. Firewall need to advertise this. Let us wait for a couple of minutes. It should be advertising. Okay, it will take some time for a firewall to advertise. Get the router info, routing table all. Now we have received 1.0, 2.0, but at a router side we are not receiving 192.168. Now let us wait. IP rep database. As of now we have not received 192.168, 10.0 and 20.0. Let us wait for a couple of minutes and we'll see. Get the router info. Okay. 192.168, 10 dot and 20 dot. Okay, this is actually not available directly on a firewall. This is a static routes. That's why it is not coming. So now let us go. We'll go to advanced and we'll say I want to redistribute a static route. Okay. Then we'll see. That should be advertised. Let us wait for a couple of minutes. Okay. Now I am advertising a redistributed routes. Show IP route. So I am getting a 10.0 and 20.0 in my routing table, right? From a firewall. Now I am getting what? Let us wait. From a firewall, I am advertising static routes, which is 10.0 and 20.0, and router able to learn that. And from a router, I am advertising 1.0 and 2.0, and firewall able to learn that, right? So with this, we will complete our RIP. Now we will go to OSPF side. Now you understood how to configure RIP in your FortiGate. Now let us see between this LAN and a firewall. We are having a static route as of now. From a firewall, if I want to go to 10.0 and 20.0, I am doing a static route, right? I don't want to do static route. Between my L3 switch and firewall, I want to learn a OSPF. So my L3 switch is having 10.0 and 20.0. He will give this particular routes to firewall. Okay? Is it clear? Hello?
Yeah, it got clear. But if we did default route here, will it work?
Default route on where?
Between LAN firewall and LAN
No, no, no,
switch.
no. See, one thing for this traffic, you should not do default route. Default route means any traffic would be going, right? Default route from a firewall should be given to ISP. Okay?
Only towards ISP.
Towards ISP, yeah. Or suppose if you want a default route, then every traffic would be going. If traffic is not matching a specific routes, then it would be going to default route only, no?
Then
Yeah.
there
So
is no use. Yes.
no, no. From a LAN side, you should do a default route. From here side, if
Hmm.
the traffic would be coming to firewall. Any traffic, if you don't want, if you want to go to internet, then you should go from a LAN side only. Okay.
Okay.
Yeah. So now we will enable OSPF on our LAN and our FortiGate firewall. So now let me enable OSPF on LAN switch first. Config T router OSPF 1. Then network I will say first directly connected network is 192.168.100.0 area 0. then another network 192.168.10.0 area 0, then another network 192.168.20.0 0.0.0.255 area 0. Okay, now we have advertised 3 directly connected networks, but OSPF neighborship will not come up. Now let us go to firewall. From a firewall, I will remove static routes 10.0 and 20.0. Okay, let us go to firewall. I want to remove this particular routes, so let me see if I can disable. Okay, I'll disable this route and I'll disable this route also. Then let us go again to CLI. We'll check routing table, get the router info, routing table all. So as of now I don't have 10.0 and 20.0 traffic, right? So let us minimize this. We'll go to OSPF now. So LAN side I am running a OSPF, right? So first thing in a FortiGate, whenever you are running a OSPF, you need to configure router ID manually. If you don't configure router ID manually, OSPF process will not start. Okay. After that, you need to create an area. So as of now, I am giving a area 0. Then what networks you want to advertise? So for now, we will advertise only directly connected network from the FortiGate side. 192.168.100.0/24. Okay, done. We will apply this thing. Okay, now I have enabled OSPF on a FortiGate also. So now on a LAN side, what you see, FortiGate neighborship, sorry, OSPF neighborship came up, right? So now let us go to again firewall. We'll see now OSPF routes are available or not. So now if you see, I am getting 2 routes, 10.0, 20.0. From where? From my neighbor 100.2, which is my LAN port number 1. Okay. Now this particular same OSPF routes I want to advertise to my branch router. So now 10.0, 20.0 I am learning from OSPF, right? And previously we have advertised static routes redistribution. So now I will remove the static routes redistribution and I will say enable OSPF redistribution. Okay. At the same time on OSPF also, from a branch, from a firewall I wanted to advertise branch routes to my switch. So I will say advertise RIP, redistribute RIP. Okay, done. So now let us go to this switch, show IP route. I am having 172.16.1.0 and 2.0, that is OSPF external routes, which means it is advertised via redistribution. You see O means it would be OSPF and E2 means external routes. Okay, you will see OSPF external type 2, sorry, where it would be E, OSPF external type 2 routes. Okay, so it is advertised via OSPF but via redistribution. So now same thing we will check on a router also. On a RIP you will not see much differences, still you will see 10.0, 20.0. Okay, so now what we have done, first thing, okay, we'll go to lab only. On this side we are having a RIP, on this side we are having a OSPF. So what switch is doing, switch is sharing this particular routes to firewall using a OSPF, and what router is doing, router is sharing this particular routes to firewall using a RIP protocol, right? Now firewall is having all the routes, firewall is having 10.0, 20.0 and 172.16, 1.0 and 2.0, right? Now these are RIP routes, these are OSPF routes at a firewall side. So what firewall wants to do, redistribute or share these routes to RIP and take RIP routes to and share this RIP routes to OSPF. So firewall was doing a redistribution of OSPF into RIP and RIP into OSPF. So this switch can learn branch router routes and branch router can learn our LAN routes. Okay, LAN routes. Now everyone is having all the routes, right? So let us advertise or let us create one policy between our LAN to our branch, and we will try to ping this PC to this PC. Okay. First, let us create a PC IPs. Show IP. I don't have IP, so I will say IP 192.168.10.100/24, then 192.168.10.1. Okay. This also I will create the IP 172.16.1.100/24, 172.16.1.1. Okay. Now we'll go to firewall again. We need to create one policy, right? From LAN to branch. As of now, we don't have that policy. If you see firewall policy, as of now we have LAN to WAN, which is port number 1 to port number 4. First, I will create a branch object, because whenever we create a policy, we need an address object, right? BR subnet. So I will say 172.16.1.0/24. Okay, done. Now we'll go to firewall policy. We'll try to create a new policy, which would be LAN to branch. What is our incoming interface here? Port number 1. What is our outgoing interface? Port number 2. Source would be my VLAN 10. Traffic is coming from VLAN 10 subnet, right? You can select multiple source. Okay, let us select VLAN 20 also. Destination would be my branch subnet. Where is my branch subnet? BR subnet. And services would be all. I don't want any NATing because I am having proper routing between my firewall and branch. I'll say all session. Okay, done. Now we will initiate a ping from this particular PC. If I try to ping 172.16.1.100, I am able to ping properly. But if I try to ping from branch, ping 192.168.10.100, I will not get a reply because there is only one way traffic, right? What we have done, we have allowed the traffic from LAN to branch. But if a traffic is initiated from branch to LAN, we have not allowed traffic, right? We have only allowed from LAN to branch. So if anyone is initiating traffic from branch to your headquarters or your DC, then you need to allow another traffic from port number 2 to port number 1, right? So now let us try to allow that. As soon as we allow, the traffic would be allowed. You can say branch to LAN, traffic. Okay. Now the source would be your branch, BR subnet. Now the destination would be your VLAN 10 or VLAN 20. Services would be all. Then there would be no NAT required. Okay. Let us try to ping now from branch to our LAN subnet. Now traffic is allowed and it is allowed, right? Is it clear? Any questions?
One question I have. You have made like one static dynamic route between LAN and branch. No, for example, RIP we have used. If we are using RIP and OSPF and LAN in between LAN switch and LAN firewall, RIP and OSPF, how it will work in that case?
No. You are saying between switch and firewall, you want to use two routing protocols. But why you
Yes.
want to use two routing protocols?
I'm just asking, like
Okay,
we should
so
not use in that case.
compared
I'm
to,
asking.
so okay, both would be used, no problem. You can use here a RIP also and here OSPF also, same thing. Okay, but OSPF routes would be taking preference compared to your RIP routes. Okay,
AD value.
because of AD value, lowest AD value. How does the routing preference happens? First, longest match, longest prefix. Second, lowest AD value, right? And AD value of a RIP is 120, OSPF is 110, correct? So OSPF
Correct.
routes would be taking preference. Instead of OSPF, if you are running here, you are running instead of RIP, if you are running EIGRP and OSPF, then it is, if the routes are internal EIGRP routes, 90 AD value, that would be taking preference. Okay, but
And you have created two policies, no, between branch to
LAN,
LAN and
LAN to
LAN
LAN,
to branch.
correct.
We have to do all the time, like this kind of scenario. I thought like we one is enough.
No, no, no. See, don't get ever confused with stateful inspection and the policy. Okay, so stateful inspection happens. Suppose I am a source. Okay, source is this, destination is this. Okay, then traffic will come to firewall. It is allowed. Okay, then traffic would be going to this. Then he will send a return traffic, right? So assume whatever the scenario it is, TCP or ICMP or whatever. I am sending a
Hmm.
traffic and he will send a return traffic, right? This time I
Hmm.
don't need a policy. This would be matching this session and this would be going out. Okay, this is okay. When he is initiating traffic, I just need a LAN to WAN traffic. But assume now he is not the source or he is not the initiator. Let us call it a initiator and responder. Okay, now my branch is a initiator and my DC is a responder. Okay, this time he would be creating any new connection, right? He will send a request, and if I don't have a policy, it will not match a existing session. Existing session was when my
If
DC
there
was
is
the
no
initiator.
session, it will not come back.
It will
If
not
there is
come.
no,
No, no.
uh,
If there is no session, first I need to check a policy, right?
hmm.
If there is no policy to allow this, it would be dropping here.
Yes.
Yeah. Okay. That was all. Then let us go to another protocol. Now what we are going to do? We were having a RIP between this, right? Now we will remove a RIP and we will try to configure a BGP. Then we will see. Branch router, config T, router. For a BGP, I will be running a eBGP. So what will happen? For a eBGP, my firewall BGP number I will give 65,000 and my branch router BGP number would be 65001. Okay, this would be eBGP numbers I would be using. So now let us see router BGP 65001. Then I will say neighbor, sorry, neighbor 10.1.1.1 remote AS 65,000. Then I wanted to advertise network 172.16.1.0. Then mask 255.255.255.0. Okay, done. Then at the firewall side, we need to enable a BGP. Let us enable. So I'll go to network. I'll say BGP. First, I will say what is my local AS number 65,000. Then I need to create my neighbor. My neighbor IP would be 10.1.1.2. 1 minute. Okay. 10.1.1.2 is my neighbor. Then remote AS for neighbor is 65,001. Okay, this is the one we are giving as of now. We will say apply this. Now let us see if BGP comes up. First, a BGP neighborship should come up, right? Okay, BGP neighborship came up. So now we will go to firewall. We'll check what all routes we have received from a BGP. The router info, routing table, all. As of now, it is saying RIP only. Get the router info, BGP neighbor 10.1.1.2. We'll say routes. As of now, I have not received any routes. We'll wait for a couple of minutes. Once the BGP neighbor sends a routes to us, then we'll see. Get the router BGP summary. Okay. Get the router info BGP summary. Okay, we have a BGP neighborship up and running, and we have received one prefix now. So now let us again see routes. Now I am having a route from a BGP neighbor. So now get the router info, routing table, all. Now if you see, previously when I was having a RIP only, I was getting two routes from a RIP, right? But now I am having a RIP as well as BGP, correct? So whichever is having lowest AD value, that is taking preference compared to that, right? If you see previous output, I'm not sure if it would be okay. Previous output is 1.0, 2.0, and both are from a RIP only, right? R means RIP protocol, learning from a RIP, and AD value was 120. We have not disabled a RIP. We are running a RIP also, and we are running a OSPF, BGP also. But now we have advertised 1.0 from BGP only, and that is the best path taken from a routing protocol, right? Is it clear?
Yes, it clear now.
So that's how it works whenever you have a routing protocol, multiple routing protocol, whichever is having the best path or based on the AD value and all, it would be taken preference. Okay. So that was all for today. You can do many things like whenever you want to do more practice of these things, you can do like a filtering or filter routes. You can on OSPF you can say I want to filter. I want to advertise only 10.0. I don't want to advertise 20.0. This type of filtering also you can apply. Okay, but see, this is not a routing class or nothing to do with the routing majorly. So I have not done much filtering and all. If you want, you can try it. Okay.
For the same path.
No, not the same path. See, whenever we are running a routing protocol, it is not for a path. It is what type of routes we
Mhm.
want to advertise to our neighbor, right?
Okay.
Yeah, yeah. Routing protocol generally learns to share the routes between the neighbors, correct?
Yes. Yes.
Okay. Yeah.
I have one like two questions.
Mm-hmm.
If we are running OSPF between in that scenario, branch to firewall and LAN to firewall, no need to do redistribution, no, because
Nothing,
both
nothing.
are same.
Correct, correct.
In case of BGP also, if we are using IBGP and EBGP also, no need to do, or
IBGP will have some limitations. Whatever I learn from my neighbor, I cannot share to my neighbor. IBGP. If you are running EBGP, then that's fine. You don't need to do redistribution.
okay, if we are running both side EBGP, no need to. Then if we are doing one side like IBGP, EBGP, then redistribution is required, like that you are saying.
Correct, correct.
Okay.
Yeah. Okay. So what we have learned today, let us see again. We'll give a quick recap. First, we have understood how does the routing decisions happen or what is the order of routing decision, right? So first we have checked what is the PBR rules, and then we have done what is the SDWAN rules. Then we have checked how does a routing table will be built if you are having multiple routes, static, dynamic, RIP, OSPF, BGP routes, which would be taking preference based on the longest match, lowest AD value or routing protocol, right? Then we have done a specific labs. First we have checked how to configure a RIP on a FortiGate firewall and how to configure RIP on your Cisco router. Then we have done a redistribution between a RIP and OSPF. So our branch router, our LAN router, and our firewall, sorry, our LAN switch and our branch router can learn routes of each other, and FortiGate can do a redistribution of that routes. Then we have removed the BGP, and we have sorry, we have not removed a RIP, but we have advertised the BGP between our firewall and branch router, and we have made a BGP neighborship. Then we have advertised the routes between the BGP, right? So these things we have done. Additionally, when we want to send the traffic from LAN to branch or from a branch to LAN, we have created a FortiGate security policy for that also, right? So any questions now?
No question.
Okay. So that was all for today's class. If you guys have any questions, please let me know. And moreover, see, I will share this particular lab guide with you guys. Okay. It would be having everything like how to configure port numbers and all, how to configure these things. Then if you wanted to advertise routes, RIP between firewall and branch router, how you can do this. remove port number 2, port number 3, firewall policy, then how to configure RIP on your FortiGate firewall, then how to enable redistribution. Everything would be given in this particular document. Okay, so you just follow this
Oh,
document. This is already shared with you guys.
yes, yes.
Okay. Okay.
Okay then.
My boy, this one, do you have a lab setup video on your YouTube channel?
Yeah. On my YouTube channel, I am having a lab setup video. How you can do a EVNG lab setup. That would be similar for your peanut lab also.
Okay.
Okay. If you go to my YouTube channel, you will find that lab. How to do a
Okay.
lab setup.
Thank you.
Okay. Yeah. And I hope you guys are
Okay.
able to see a recording of every day.
Yes, yes, we are getting